Okay, so we have these absolutely incredible, massive AI models, right? They can write, they can code, they can create all sorts of things. But what happens when you want to teach one of them a very specific new skill? Well, it turns out that's a surprisingly huge challenge. And that's really the big question here. I mean, we're not talking about some small program on your laptop. We're talking about models like GPT-3, which have, get this, 175 times billion individual knobs or parameters that basically define everything they know. Just trying to tweak a tiny fraction of those, it's a monumental task. The standard way people have done this for a while is through something called fine-tuning. The idea is pretty simple on the surface. You take that huge pre-trained model and you just keep training it, but on a much smaller, specialized set of data. This nudges all those billions of parameters, so the AI gets really, really good at that one new job. Sounds easy enough, right? Yeah, well, not so fast. And this is where we run into what you might call the custom AI challenge. Let's use an analogy. Think of a big model like GPT-3 as a master architect's complete, super detailed blueprint for a massive skyscraper. Fine-tuning, then, is like taking that blueprint and making a few changes. Maybe you're redesigning the penthouse for a special client. The problem, as you might guess, is the sheer scale of that blueprint. Yeah, that number, that is the absolute heart of the problem. In our skyscraper analogy, it means the blueprint has 175 billion individual lines and measurements. So when you want to make one tiny change, you're not just adjusting one little part. You potentially have to check and re-verify everything else to make sure the building doesn't fall down. It's a lot. And the researchers who actually came up with the solution we're going to talk about today, they put it perfectly. The cost is it's staggering. Think about it. If you want one version of GPT-3 that's an expert on legal documents and another one that's a pro at writing marketing copy, you'd need two completely separate, gigantic models. Let's go back to our blueprint analogy. The old way of doing things, full fine-tuning, is like having to photocopy the entire 350 gigabyte skyscraper blueprint for every single change. So you have one massive copy for the legal expert, another for the marketing expert, another for medical summaries. You'd literally need a warehouse just to store all the blueprints. It's just completely impractical. So naturally, people tried to find some workarounds. But as you can imagine, these early attempts to be more efficient, well, they all came with some pretty serious trade-offs. Okay, so on one hand, you've got full fine-tuning. We've already established that's super expensive and bulky. On the other hand, a clever idea came along called adapters. Now, going back to our skyscraper, adapters are kind of like adding a few extra specialized floors on top of the building. It's a smart workaround, but there's a catch. Every time you need to get information, the elevators have to go through these extra floors, and it slows the whole system down. This slowdown is called inference latency, and for anything that needs to be fast, it's a total deal breaker. But what if there was a better way? A much better way? This is where a brilliantly simple and clever trick comes into play. It's called LoRA, which stands for Low Rank Adaptation. So the core insight behind LoRA is this kind of radical shift in perspective. The researchers had a hunch. They thought, what if the model is complex, but the change we need to make is actually really, really simple? They realized that the instructions to teach the AI a new skill could probably be compressed down into a tiny, much more manageable package. And here's the key idea, the central analogy for LoRA. It's not about redrawing that giant blueprint at all. Instead, it's like creating a small, transparent overlay, like a piece of tracing paper, that you just place on top of the original. This little overlay only has the new information on it, just the changes for your specific task. The original blueprint stays exactly the same, totally untouched, and this overlay is tiny and super easy to swap out. So here's a quick rundown of how it actually works under the hood. First, you freeze the original model. You lock it down. None of those 175 billion parameters are going to get changed. Then you inject a couple of really small trainable modules into each layer. This is our transparent overlay. And here's the magic part. You only train these tiny new modules on your task. That's it. When you're done, you just merge that small change back into the main model, and boom, you get the new skill with absolutely zero slowdown. And this simple idea, well, It led to some truly dramatic results. It basically turned something that was prohibitively expensive into something that's now widely accessible. I mean, the sheer scale of the improvement here is it's incredible. Instead of training billions of parameters with LoRA, you might only need to train a few 100,000. We're talking about a reduction of up to 10,000 times. That's not just an improvement, that's a massive leap in efficiency. And that efficiency has a huge practical benefit. Because you're training so much less, LoRA cuts the amount of GPU memory you need by up to 3 times. And that is what really lowers the barrier to entry. It makes creating custom AI accessible to way more developers, researchers, and pretty much anyone with a good idea. But here's the real kicker. You get all this amazing efficiency without sacrificing quality. In fact, in a lot of cases, like this summarization task you see here on GPT-3, LoRA actually performs a little bit better than the old full fine-tuning method, all while being thousands of times smaller. It's just wild. And so, critically, it solves that big problem that plagued the adopter method. Remember the slow elevators? Because the small changes are just merged right back into the main model, there's absolutely no extra slowdown, no latency. You get the full speed of the original model, but with the new specialized knowledge baked right in. Okay, so let's zoom out a bit. What does all this mean for the future of AI? Why is this one clever trick such a massive game changer? Well, the real power of LoRA is that it completely transforms AI customization. It takes it from this heavyweight industrial-scale process and turns it into something light, fast, and flexible. You can have one giant base model, and then literally thousands of these tiny LoRA overlays that you can just swap in and out instantly. It makes building specialized AIs cheaper, faster, and accessible to pretty much anyone. And that leaves us with one last really fascinating question to think about. For years, the power to create these custom, large-scale AIs was really only in the hands of a few giant companies. But now that that barrier is, well, it's pretty much gone, so what happens next? What incredible, niche, and personalized tools are we all going to build now that anyone can teach a giant AI a new trick?